Thank you so much for watching this online video tutorial. Like, comment, and share, as well as subscribe to our channel at Good Better Best Online Videos for more video content. Alright, grade 12s, thank you very much for joining me tonight on this beautiful Wednesday evening. Okay, I got a question from one of you guys, one of the ladies actually in the room, requesting help with a question, so I decided to save it here for everybody. Question 6 is from a website here called downloaded from stanmorephysics.com, where we find department papers. So this is a department paper. This is an NSC paper of the June supplementary of this year, 2021. And we got a question here. That's question 6. Says pure hydrogen iodide gas, HI, of concentration 1 mole per decimeter cubed is sealed in a 500 cubic centimeter container at temperature T. The reaction reaches equilibrium according to the following balanced equation. 2HI gas gives us hydrogen gas plus iodine gas. Okay. Now define the term chemical equilibrium. I'm sure we all know how to do that. Chemical equilibrium is the stage in a chemical reaction where rate of the forward reaction equals rate of the reverse reaction. Okay, that's pretty simple enough to understand, I guess. I think. Okay. And then 6.2, the graph below shows how the concentrations of the reactant and products vary with time during the reaction. We've got concentration versus time. And they ask which one of the curves X or Y represents the changes in concentration of the products. Give a reason for your answer. Okay. Well, just off the top of my head, it looks like X. Alright, because the concentration of the products definitely increases over time. The concentration of the reactants decreases over time. Alright. This is all from 0 to 6 minutes, of course. And then no products obviously were present initially as well. That could have been another reason. And let's see, the curve also begins at 0. So here, of course, Y starts at a certain concentration and then goes down. But here, obviously, curve X begins at 0, so it climbs up. So that's definitely the changes in concentration of the products. Okay. 6.2.2, does the rate of the forward reaction compare to that of the reverse reaction? At T equals 4 minutes, choose from higher than, lower than, or equal to. Oh, sorry, not does, but how does. So how does the rate of the forward reaction compare to the reverse reaction at T equals 4 minutes? Choose from higher than, lower than, or equal to. Well, the rate of the forward reaction at T4 to the rate of the reverse is going back that way. This is going back that way, so definitely see that from 0 there, from 0 there. So it definitely looks like higher than is the forward reaction. The forward reaction, of course, going from reactants to products. So forward reaction is always, I think, from left to right. So yeah, I think that is the forward reaction. Well, forward, I think, is also the formation of products. So yeah, I'm gonna go with that it is higher than. The equilibrium constant Kc for the reaction is 0.04 at temperature T. Calculate the number of moles of iodine present at the time T equals 6 minutes. Okay. Alright, so this one we're going to have to construct our little table. Okay. First of all, sorry guys, the number of moles of hydrogen iodide, okay, is equal to, well, of course, C times V, which is equal to the concentration is 1, and we've got 500 cubic centimeters, so that's 0.5 decimeters. That's equal to 0.5 mole. Okay, so let's construct our little table. I'll pause the video while I draw it. So here we got our table. And if you can't see that, guys, let me write it in another color. We've got a balancing number here of 2 in front of the hydrogen iodide, obviously because we've got H2 and I2, so we've got a 2 in front to balance out the equation. And we found the initial mole of hydrogen iodide gas to be, I'm going to write it in its color, of 0,5. And of course these will be our products, so they'll be 0 and 0, so let's write it in their colors too. So that's the first part there. Now we don't know the change in moles, okay, but we know that there's a 2 in front of here, so this is going to be 2x, right? And these two would just be x and x as well, because we don't know what was this change. Of course these two will remain the same, but the quantity of equilibrium of hydrogen iodide gas would be 0,5 minus 2x. Alright, 0,5 minus 2x. That would be the, obviously the equilibrium would be the initial minus the change to get equilibrium. And then, of course, this would be obviously the concentration. The formula C is equal to, well, whatever this is, divided by the volume, which is 0,5, and this would be, of course, x divided by 0,5, and the same thing here, x divided by 0,5. Now I'm warning you, this calculation is going to get messy. Okay, so those watching, I'd grab a screenshot of this because I don't have any more space to move on. So even I'm going to grab a screenshot of this on my side so I can work with this. Alright, cool. So I'll grab my screenshot. Okay, let's just turn it around. Okay, great. So this is going to get messy, so I'm going to take this away quickly. Hope you got your screenshot. Okay, so of course now you got to go to the formula now, and of course you got to say, well, Kc is equal to my products, which is H2, concentration of H2 and I2, all divided by Hi squared, because of the balancing number 2 in front of it. Now we had the equilibrium constant with 0,04, and just to go back to the question again, the question is calculate the number of moles of iodine gas, okay, which would be the same for which would be the same for H2 as well, because they are in the same mole ratio. Okay, so we've got x divided by 0,5, divided by 0,5 for both of those, so x will just be the amount of moles for everything, and then we got obviously 0,5 minus 2x, okay, divided by 0,5 all squared. So what we did here is we realized that we could take care of the top and add in, just multiply the two top fractions, so we end up with x squared over 0,25. And then the bottom part, we realized we could break up the square to square the top, the numerator, and square the denominator. We end up with 0,5 minus 2x all squared over 0,5 all squared. If we separate it, we'll actually know we've got this top fraction divided by this bottom fraction. So if we're going to multiply it, they invert. Okay, so simple, think this is grade 7 fractions. So then the 0,25 will cancel with this 0,25, okay, which will leave at the bottom here 0,04 equaling to x squared all divided by 0,5 minus 2x all squared. Okay, so what we can do is just go to a new page, and then we can have sorry, that's wrong. Where's the layer? Is this the layer? Here we go. So then we can have, of course, 0,04 multiplied by 0,5 minus 2x all squared is equal to just x squared. Alright, now to maybe sort this side out first, we could just divide both sides by 0,04. and then we'll have 0, 5 minus 2x all squared will equal x squared over 0, 0.04. Now this is the same over here. If we just work with this first, this is 0, 5 minus 2x over here. I think this is not an inequality but a quadratic. So we're going to have 0, let's just maybe just rule off a little section here quickly. And we'll get back to that. Alright. You just think about this. Okay. So that's going to be 0, 0.25 multiplied there. Then we're going to have, let me see, hold on a second, 0, 0.5 times 2. Then we're going to have minus x, alright, plus 4x squared. Okay, so to solve, that's obviously going to equal 0, 0.25 minus 2x plus 4x squared. Alright, that's what we're going to do. Okay, so now we can obviously gosh, this is actually getting very, very messy. There's no easier way to do this. You gotta do it this way. Let me just think this through. Okay, cool. So you got that on the one side here. So coming back now, let's just rule off another section. There we go. And just rule off this section here. Okay. So we got this now, 0, 0.25 minus 2x plus 4x is equal to now x squared is equal to x squared all over 0, 0.04. Okay. Alright, this is going to get extremely messy. Okay, cool. So if you take the other side, if you take this over back again, 0, 0.04, apply that out, we'll have 0, 0.25 times, hope I haven't made a mistake in this because this is going to be very annoying, 0, 0.25 times 0, 0.04, that's going to be 0, 0.01, and then 0, 0.04 times by 2, that's going to give me minus 0, that's going to be 0, 0.08x, and then that times by 4, that's going to give me plus 0, 0.16x squared. It's going to equal x squared. Okay, so now I've got to go ahead and say, well, this coming over, or let's take that over, so I'm going to have 0, 0.01 minus 0, 0.08 x is going to equal because that's 1 on the other side, 1 minus 0, 0.16, 0, 0.84, 0, 0.84x squared. And so grade 12, after much solving, okay, we are down to this formula over here. I think this is where we ended last, and then I paused the recording just to make sure I was right. And a lot of help was with students. Thank you so much for obviously helping me out. Also, we both arrived at the answer together. So we got this little formula here, 0, 0.84x squared plus 0, 0.08x is equal to 0, 0.01. We push it over to get a quadratic equation, just like we had over here. 0,84x squared plus 0,08x minus 0,01 equals to 0. Okay. Now, unfortunately, we have to bring in our maths brains here and apply the quadratic formula, which we did over here. Okay, the quadratic formula for mathematics is x is equal to negative b plus minus square root of b squared minus 4ac all divided by 2a. So I wrote our little formula there, or equation, and we got a, b, and c there. Okay, and with that being there, we just sub it in here. So x is what we're looking for. So let me go back to the green color. X is what we're looking for, so that is equal to negative 0,08 plus, we'll do the plus first, and the minus, we don't want the minus answer, we want the positive answer, of course. So we're just going to do the positive, and we're going to have b squared, so that's 0,08 all squared, minus brackets 4 times 0,84 times, because of the negative there, minus 0,01. Just extend our lines here because it's quite long, all over 2 times 0,84. If we do this, we'll get the answer that x in this formula, in this equation, which is actually the number of moles. I think, can't remember the question now. Let me just make sure I remember the question. The number of moles of iodine gas at 6 minutes is equal to about 0,071 mole. And that is our final answer using the mole method. Of course, there is another method which you can use, and that's the concentration method, or the concentration table only, which I will demonstrate second. Okay, now the mole one was a little bit hectic. Well, this one was a little bit more hectic than the concentration one. Is a little bit more simpler. However, most people might understand the mole approach, which we did first. So if we go back and I think we started all the way here. The way we did was great. Okay, and we ended up here with this one. And then we got obviously to our little quadratic here. And then we just had to obviously use a bit of mathematics and use the quadratic equation to obviously solve for x, because hey, we have it, so might as well use it. All right, cool. Let's do that other method. This is the concentration method. So initially we had 1 mole, because remember in the question we had 1 mole per decimeter cube of HI, and of course we had no concentration, no product. Moles or concentration, that was all 0 in the what's the thing, the graph, sorry, the graph was it started from 0. Okay, and now the change in concentration, remember there is still this balancing 2 over here. Okay, so we're going to of course call that now 2x as well, and that'll be x and that'll be x. And then, of course, the equilibrium concentration will obviously be 1 minus whatever the change in the concentration was. Okay, and these still will remain the same, unknown. Okay, so we got enough to start the ball rolling here. Let's change it to a bit of a lime green. Kc is equal to, we know the formula, so I'll just sub in. Oh no, let's actually have H2. Concentration of I2 all over HI all squared. So that's 0,04 is equal to x times x all over 1 minus 2x all squared. Okay, now to continue, of course, we're going to have 0,0. Let's just wall this up. And maybe make this a little closer. 0,04 is equal to, of course, x squared on top. And then to solve for the bottom, okay, we're obviously going to have, I think if I can do this by I. No, I'm not going to do this by I. Let's actually just do it properly. 1 minus 2x minus 2x. Okay. So if we can do that, we'll have 0,04 is equal to, again, x squared all over, well, that's going to be 1 times 1 is 1. That's going to be minus 2x. Minus 2x, that's going to be minus 4x. And because I mean, like, minus 2, minus 2, minus 4, and then plus 4x squared. Okay, that's what's going to be there. So what we can do is we can take that all over to have 0,04 multiplied by 1 minus 4x plus 4x all squared is equal to x squared. Great. And let's see what we can squeeze in here. Alright, so if we do that, we're going to have 0,04 minus, let's say 0,04 times 4 minus 0,16x and plus 0,16x squared is equal to x squared. So if we take everything over, let's see, that's going to be 1 minus, so I'm going to have 0,04 minus 0,16x is equal to 0,84x squared. 0,04x squared. So that's going to have 0,04. So if I make this everything on 0, I'm going to have 0 is equal to 0,84x squared plus 0,16x minus 0,04. And that's going to be my final equation, is equal to 0. Okay. So we are going to need to apply the same quadratic formula again to this equation. So if we come here to the quadratic formula, we'll have x is going to equal, of course, negative b plus square root. And let's just make this a nice long line. B squared minus 4ac all over 2a. So let's do the same thing. So minus, what was b? 0,16. Okay. Minus 0,16 plus square root 0,16 all squared minus, let's check, is it minus? Yes, minus 4 times 0,84 times minus 0,04 all over 2 times 0,84. Okay, so let's just take time to put that in our calculator. So negative 0,16 plus square root bracket 0,16 all squared minus 4 times 0,84 times 0,04 all over 2 times 0,84. 0,84 minus. Sorry guys, I keep making the same error. I don't have any paint left on my calculator, so I can't see which key is which, so I have to really, there we go, that's right. Correct. Okay, let me see if I correct. Yes, so we'll get x, so therefore x will equal 0,14285, so that's 0,43. But remember, this is the concentration method, so this is mole per decimeter cubed. Now we need another calculation to say, well, N of iodine gas is going to equal, of course, C times V. So that's obviously going to equal the concentration, which is 0,143, multiplied by the volume, which was 0,5, and then that's going to equal 0,5, answer 0,071, because I took the entire answer. If you just take this number times that, you'll get 0,072 mole, and they'll still mark it right, but you want to get the same accurate answer, it'll be 0,071 mole if you use the entire 0,14285. Okay, and that's our final answer using the concentration method. Unfortunately, you just had to use the quadratic equation, so you had to involve a bit of math skill here. And that is where we'll end things there for tonight, grade 12s. Thank you so much for one of the students to providing us with this question to go through for our session tonight. It was wonderful, and a bit of a difference in questions. We've never seen a question like this before. We had to use the quadratic equation, but it just shows that maths doesn't entirely disappear from our lives. So let's beware for these things, especially those that are writing our second paper, our chemistry paper this week. Wish you all best of luck for those that are in class. Anybody else that is writing after they watch this video, wish you all the best of luck for your exams as well. And please don't forget to like and comment on this video, and we will catch you in the next one.